Well, hi everyone, and greetings from Northern Michigan. This is Bob, the Science Guy. This isn't a regular video. This is just going to be a quick tutorial on how to use a program or a website called SkyVector.com to figure out flight paths. Now, many times in the flat Earth, the question of flight paths and great circle courses come up. So I thought I'd teach you guys real quickly how to do a flight path. So let's go ahead and see what we have here. So you open up SkyVector and you'll see something that looks like this. Now, in a recent video I did on Phuket Word, there was talk of a flight from New York to Tampa to Los Angeles and back to New York. I'm going to show you how to do that. First of all, kind of center New York in the screen just so it is where it needs to be. And we're going to zoom in on it a little bit. Now you see these symbols here? You got these circles and then you have these little lines. These are airports. So if you right click that airport, you'll see it's John F. Kennedy in New York. Hit plan. Now go back down here to the lower right corner and zoom out a little bit. Let's go on down here to Tampa and do the same thing. So there's Tampa right there, see? So we're going to zoom in a little bit and we're going to find Tampa International. And there it is, see? Now we're going to right click it and hit plan. Now it draws a course from JFK in New York directly to Tampa. Now we're going to repeat the same thing. And we're going to go on out here to Los Angeles. Now Los Angeles has a lot of little airports in it and some really big ones. So we got to find the right one. Now, you see this big circle here? Okay. Right there should be Los Angeles International, LAX. Hit plan. Now we're going to zoom back out again. Notice that's a little bit of a curved line. That's because it's a great circle course. And now we're going to go on up here. And once again, we're going to go to JFK and hit plan. And now, look at that. We have a course from JFK to Tampa to Los Angeles and then back to JFK. This is a triangle on a great circle course on a spherical Earth. Now, if you want to see the flight path, go right up here to Flight Plan, which is right under the SkyVector sign. And you'll see, New York is where we depart. We end up back in New York, and we go by way of Tampa and Los Angeles. Now, if you go down here to the nav log, click that. And we can actually make that a little bit bigger if you'd like, just because my eyes aren't all that good. But here is a flight path. This is the actual flight plan for that, and you can fly this flight plan. Now, here we are, JFK to Tampa to LAX, back to JFK. Now, over here, you're going to see TH. That stands for true heading. And underneath it is the magnetic variation, but we don't want the magnetic variation. We just want the true heading. So the course from New York to Tampa is 224 degrees. The course from Tampa to Los Angeles is 291 degrees, and when we get to Los Angeles and want to go back to New York, we're going to go 62 degrees. Now these are the true headings to true north. These are not magnetic variations. That's what this negative 12 plus 13 is. Okay? Now, here's a quick word to the wise. Let's look at Tampa. Say we want to calculate the angle between New York and Los Angeles with an apex of Tampa. Now, going to Los Angeles is easy because we know that it's going to be 291 degrees from Tampa. But how did we get to Tampa? We had to go down 224 degrees, but that's going into Tampa. How do we figure out what it is going out of Tampa back towards New York? We'd subtract 180 degrees because we're going the opposite direction. So that will be 44 degrees that will go back up to New York, and then we'll leave out at 291 degrees. Now with that, you can calculate the angle of that corner of the triangle. So let's do another one real quick. So we'll clear this, and we'll go back over here. We're going to clear all of this, just zero it out. So let's do this one just a little bit different. Now we're going to start off at JFK, but say we know the names of the airports that we're going to. So we're going to go ahead and we're going to just type them in. So we're going to go from JFK to LAX, put a space in, then we're going to go up to Ted Stevens in Anchorage, Alaska, which is PANC, and then we're going to go back to JFK. So here's our flight path. We're going to start in New York, and then we're going to go through this route, and we've typed in our numbers. So we're going to go ahead and hit return, and there's our route. Now, the same way we calculated the internal angles of this triangle when we did our Tampa route, we're going to do it here. We're going to go to Navlog. We're going to make it a little bit bigger so that we can see it because we're old. Now, JFK to Los Angeles, our heading is going to be 279 degrees. So, when we get to Los Angeles, we came in at 279. So if we wanted to look from Los Angeles back to New York, what would that be? Be 99 degrees, right? So we've got 99 going out of Los Angeles back to New York, and then we have 338 going up to Ted Stevens in Anchorage, Alaska. So we can calculate our angle there. Likewise, we can calculate an angle from Anchorage, Alaska. We came in from LAX at 338 degrees. We want to take 180 degrees from that, and we're going out at 75 degrees, so we can calculate the angle there. Then we can do the same thing with New York. We can calculate an angle back to Anchorage by adding 180 degrees to this 75, and then we've got our original course down to Los Angeles, so we can get that angle. Now go ahead and have a look at that, and you will find that if you add those angles up, they come to 205 degrees. Now because they're not 180 degrees as would be required on a flat Earth, that means that the Earth by definition is not flat. And if you look back here at this route, this is the actual countryside that plane will fly over. This is not just a curved line. You can actually look for airports along this line, and that flight path will go right over it. Now for an interesting exercise, here's one other thing that you can do. We're going to go back here to the flight log. We're going to get bigger, and our total distance is right here. 2941.9 nautical miles. Now go back and print this map off and draw a straight line from here to here. Not this curved line, but a straight line. And then find an airport somewhere right in here where that line comes over, and then add that into your flight path and see how long the distance of the flight is by making straight lines between these points would be. You'll find, surprisingly, that it's much longer. Well, this is Bob the Science Guy. I hope that you had an opportunity to pay attention here and learn a little something about SkyVector. So if somebody starts talking about a flight from, say, Los Angeles to Taiwan having to divert to Alaska, you can rather quickly and straightforwardly find out why they went to Alaska instead of Hawaii. So thank you very much for your attention. Hope it found it enjoyable and informative. Take care, guys.